Okay, today we are just going to kind of put it all together, and we are going to complete our notes transformations with quadratic functions. You wouldn't believe this, but I went to edit the video that I already had made, and I deleted it. I'm an idiot. So anyways, here we go. Alright, so here we go. This kind of puts it all together. We have use a calculator to generate a table of values for the function y equals 2 parentheses x minus 3 squared plus 4. So let's do this. Let's go ahead and go to y equals. Everybody needs to put this in, and we are going to do 2 parentheses x subtract 3 parentheses squared plus 4. And I'm going to hit second and graph, because all they're asking for is a table. And so I'm going to have to go where x is 1. It says my y value is 12. When x is 2, my y value is 6. When x is 3, my y value is 4. When x is 4, my y value is 6. When x is 5, my y value is 12. When x is 6, my y value is 22. Next, simplify the function by squaring, distributing, and collecting like terms. So now we're going to do this manually. So we have 2, I'm sorry, you can't even see what I'm doing here. We have 2 times x subtract 3 squared. Well, what we're going to do here is we're going to take that x subtract 3 squared, and we're going to write x subtract 3 and x subtract 3. So plus 4. Hope y'all understand what I just did. I'm going to use FOIL now, and I'm going to do x times x, which is x squared, and x times negative 3 is negative 3x, and I know it has a plus sign there. We're just going to kind of ignore that. And then we would do negative 3x, and then plus negative 3 times negative 3 is plus 9 plus 4. So we're going to continue. Now we're going to distribute. Okay, and by distributing, we're going to do 2 times x squared. Well, we're going to clean this up first. I'm sorry. Let's do x squared, and minus 3 and minus 3 is going to give us a minus, I'm going to clean that out because that's going to drive me nuts, 6x plus 9 plus 4. Okay? So then we've got y is equal to, now let's distribute our 2. 2 times x squared is 2x squared. 2 times negative 6 is, get rid of that, negative 12x. And 2 times 9 is 18, and then plus 4 still. Then we're going to clean that up, and we end up with 2x squared minus 12x plus 18 plus 4 is 22. Would this expression generate the same table of values? Of course it would. Okay? If you have any question about that, you can use your calculator and make sure the answer is going to be yes. These equations are both examples of a quadratic functions. Okay? More importantly, these equations show the 2 special forms of these types of functions. And the special forms of these types of functions are the standard form and the vertex form. And those are on your mathematics chart. We've gone through these already, but we're just kind of putting this all together. And so the standard form here is y is equal to, or f of x, either way. I want you to learn that that is just, those are interchangeable. ax squared plus bx plus c. And that is the simplified form. Okay, the vertex form is, and you could use f of x or you can use y, is equal to a times x minus h squared plus k. Okay, and so when you know this, you will know that your vertex is actually your h and your k. Okay, the transformation of the parent function sketches graphs and determines equations from a graph. It's very easy to determine. Transformation effects, when you have a quadratic function, is given in the vertex form, y equals x squared form. The parent function, y equals x squared, undergoes the following transformations. Okay, so here we go. The function reflects over the x-axis if it is negative. So if your whole in function, or your a value, is negative, then it is going to go reflect over the x-axis. That's when you have your parabola opening down. Okay, we have a here. Okay, what happens and what does a do? Okay, the graph stretches or compresses by a factor of the absolute value of a. So when a is greater than 1, okay, you get a stretch. Right? If the absolute value of a is greater than 1, the graph stretches. All right, vertically. And when it stretches vertically, we've talked about this, what happens is it narrows your parabola. Okay, so in other words, from the parent function, it ends up creating a narrowed version from the parent function. It's going to look closer to a V when you look at it. If your absolute value of a is greater than 0 but less than 1, the graph compresses vertically. Compresses vertically. We've talked about this. Means it widens. Okay, it's pulling it open. The parabola widens the parabola. Okay, and so that makes it more of a flat. It looks more flat. All right. What does the k do? Well, the k, the vertex shifts k units. If k is positive, it shifts up. If k is negative, it shifts down. Remember, here's your k. Okay, so k makes your parabola either go up or down. Your vertex, I'm sorry. Okay. H. What does h do? Well, the vertex shifts horizontally h units. So your h is here. If h is positive, meaning this is what it's going to look like, okay, this part is going to stay, it shifts to the right. All right. If h is negative, do you see how your negative sign on your h? So really, when you wrote it, it would end up right here being x plus h, right? Okay, so this means that your h value is negative. So so your vertex shifts left. So h makes things go either right or left. So the vertex of the parabola is always your coordinate at hk. So this is kind of just an overview of everything we've kind of done. We're going to do a few of these, and then you're going to have a few practices, and they're going to be looking just like this. There are several steps you're going to do. You need to make sure that you are doing all your steps. It says here, sample problems from the quadratic function. State if there's a reflection over the x-axis. Identify any vertical shift, identify any horizontal shift, identify any vertical stretch or compression, and by what factor. Determine the standard form of the quadratic equation, and F is for sketching the graph of the parent function. So each one of these is going to be part of what you're going to be doing. Now, I'm going to do a little map for myself up here. Okay, remember that if it is a negative function, that means it's reflected. Okay, it's going to open up downward. I'm going to write my vertex form, a times x minus h squared plus k. All right, so k gives me my vertical shift. Vertical shift. Okay, I'm sorry, I moved that off. All right, my H is the horizontal shift. Okay, and my A tells me whether it is a stretch or compression. Okay, so here we go. Just looking at this, I know that my H is a positive 2 and my K is a positive 4. So I can tell you right now, just looking at that equation, my vertex is at 2, 4. Okay? Now they have drawn the parent on here so that we're comparing what we have. Alright? So it says, state if there's a reflection over the x-axis. Now, to be a reflection over the x-axis, what would I have to have? I'd have to have a negative sign out here. Remember, right now my A is 1 because there is no other number there. Alright? And it's positive. So I'm going to write no reflection. Okay? B, identify any vertical shift. Well, what do we have here? We have vertical shift is K, so it's plus 4. So we're going to say up 4. Okay? Then it says identify any horizontal shift. So here's our horizontal. It's H, so it's a positive 2. So what way are we going? It's going to be right 2. D, no stretch or compression. Okay, does it have a stretch or compression? Is this number greater than 1, less than 1, between 0 and 1, or is it greater than 1? No, it is 1. So no stretch or compression. Okay, so E, they want you to write the standard form of the quadratic equation. Alright, so we're going to go here and we're going to write our vertex form. Number 1, y equals 1 times x minus 2 squared plus 4. Alright, so here we go. I know you all love to do it, but we're going to do it, alright? So we've got x minus 2 times x minus 2 plus 4. So you're going to use FOIL, and I'm going to end up with x squared minus 2x minus 2x plus 4, and I'm going to put all that together, and I'm going to end up with x squared. I've got minus 4x, and I've got plus 8. And there's my answer. Okay, so that didn't take very long. I'm going to write x, I'm going to write right here my answer, y equals. Remember, if it says an equation, you got to have y equals, or fx equals, whichever one you want. X squared minus 4x, sorry about that little dot up there, plus 8. Now I'm going to go graph it, and I'm going to use a different color pencil just so you can kind of see it. I'm kind of scattered here. So I've got a vertex at 2 and 4. So I'm going to go over to 2 and up to 4. And here is my vertex. Okay. So then I have what? What can I do here to plot this? What would make it easy? Well, I know that I'm going over and up 1 because there is no vertical stretch, and that's what the parent does. It always goes over and up 1, so I can go over 1, up 1. Here's another one. I'm going to do it with just this because my colored pencil is just 2. It makes it, they're not sharp enough. All right, and then I know since there's no vertical stretch, I can go over 2 and up how many? Do you guys remember? 4. 1, 2, 3, 4. And here over 2 and up 1, 2, 3, 4. So here is the parabola for that equation. Okay? So let's do number 2. Number 2. So here, do we have a reflection over the x-axis? Well, yes, because we have this right here. So we're going to write yes. And then B, identify the vertical shift. So which way is the vertical shift? Well, I see the vertical shift as a -5, so that tells me I'm going down 5. All right? By the way, what is my vertex? Who can identify the vertex? Hope you wrote 4 and -5. Okay? Because this is a +4 and that's -5. All right? So C, it says identify the horizontal shift. So the horizontal shift is going to be what your H value is. So it's positive, so we're going to go right 4. And D is vertical shift or compression. Do we have a vertical shift or compression? Is the number that's out here between 0 and 1, which would be a compression, or is it greater than 1? No, it is 1. It's a -1, so no stretch or compression. Okay, and then it says we need to do our equation in standard form. So number 2, I'm going to rewrite my equation. Y equals -1 times x minus 4 squared minus 5, -1 times x minus 4 times x minus 4 minus 5, -1, I'm going to use FOIL, and I'm going to end up with x squared minus 4x and minus 4x. I guess I'll write that out. 4x and minus 4x, and -4 times -4 is +16, minus 5. Make sure you keep your parentheses so that you are keeping things where they should be. Okay. Now I've got to clean up this mess in here. I've got x squared minus 8x plus 16. Combine my like terms, and that's minus 5. -1 times x squared is -x squared. -1 times -8 is +8x. -1 times 16 is -16. And then I need to make sure I include my -5. Now I just need to clean this up, combine like terms. -x squared plus 8x, -16, and -5 is -21. So I am going to rewrite that here. And I'm going to make sure I have y equals, because remember an equation must have a equal sign. -x squared plus 8x minus 21. Okay, then I'm going to graph it, and I'm just going to use my pencil. So we are going to start at our vertex, which is over 4 and down to -5. 1, 2, 3, 4, 5. So here it is. Okay. And it says it does not have a stretch or a compression, so we know we're just going to go over 1, down 1, over 1, down 1. We're going to go over 2, down 1, 2, 3, 4, over 2 and down 1, 2, 3, 4, and I can draw my parabola. Pretty simple. Okay. All right, so here we go. We're going to go to number 3. So number 3, let's look at this. A, is it reflected? No reflection. It is a positive A. Okay. B, is there a vertical shift? Yes, there is a vertical shift, and it is down 4. So we're going to go down 4. C, is there a horizontal shift? Well, this is a plus, which tells me it started out as a minus, okay? So that means that it's going left 3. I guess we should have identified our vertex at first. Just looking at your 3 and your 4, you should know that your vertex is -3, -4. Okay? All right. Here we go, D. Vertical stretch. Yes, it is, because this number is greater than 1. So vertical stretch And the other thing that we have to notice up here, it says, and by what factor? So our scale factor is 2. Okay? Now we need to find our our quadratic equation in standard form. So we're going to go number 3 on our paper, and we are going to write y equals 2 times x plus 3 squared minus 4. Then I'm going to do 2 times x plus 3 times x plus 3, subtract 4. And I've got 2, I'm going to use FOIL, and I've got first is x squared, inside is plus 3x, outside is plus 3x, and last is plus 9, subtract 4. And then I have to clean that up. 2x squared, 3x and 3x is plus 6x plus 9, subtract 4. Distribute my 2 times x squared, 2x squared, 2 times 6 is plus 12x, 2 times 9 is plus 18, subtract 4. Alright, now I need to combine my like terms there. 2 plus 12x, 18 subtract 4 is going to give me plus 14. So I'm going to come over here and write my equation using a y equals 2x squared plus 12x plus 14. Then I'm going to go and do my graph. Okay? So, when I do my graph, remember that you are doing a vertical stretch. That means you have your 2 over your 1. So, when you're going to go over 1 and up 2. Okay, so we are going to start at our vertex of -3, -4. So -3 and -4. Okay, and then you're going to go over 1 and up 2. Over 1 and up 2. Over 1 and up 2. And then we are going to go over 2 and up 4. Over 2 and about. Okay, if I really wanted to be perfect on it, I would come back to here and I would do this, and I would do 2x squared plus 12x plus 14, and I would hit second in table. And let's see, when I'm at a negative, oh, I should have gone over 1. When I'm at -1 on x, we've got that. We're at -1, and we're at -1 on x is right here. We would be -2 is -2, -1 would be at 4, so we need to go 1, 2, 3, 4 up. And here, when we're at -4, we're at -2, which I have, and then -5, we would be at +4, because remember we've got a axis of symmetry, so -5, we would be at +4. So that gives you a better picture, because that's the better way to go. Okay. And there we go. Okay. Alrighty. Let's go and do the last one. Where is our vertex here? Can you tell me? Well, this is a positive, so obviously it's negative. And what about your H? What about your K? That was your H. What about your K? Where is it? Oh, it's not there, so it must be 0, because remember, we are lazy. We don't write it, okay? So, does it have a reflection? Nope. It does not have a reflection. So, no reflection. Okay? And what is your vertical shift? Is there a vertical shift? Anybody tell me? Nope, because remember this is 0. So no None. You could write none. C is identify the horizontal shift. Well, we're going to go left 5. Okay. D says identify any vertical stress or compression, and by what scale factor? Well, look at this. It is greater than 0 but less than 1, so we have a vertical compression. And remember, when it's a compression, it just means it's going to look wider. Alright, our scale factor is 1/2. And now we need to figure out what our equation is. Number 4, we have y is equal to 1/2 x plus 5 squared. Okay, and we've got 1/2 x plus 5 times x plus 5. I'm going to use FOIL, and I'm going to do first is x squared, 5x plus 5x plus 5x, and then 5 times 5 is 25. Need to clean up inside first. 1/2 times, well, x squared, 5x and 5x is plus 10x plus 25. Now, you can do this the hard way or the easy way. You can do it by 1/2. I prefer to deal with 1/2 because then it tells me I'm going to go over 2 and up 1. So I'm going to do 1/2 times x squared, and I'm going to leave it as a fraction. And then I'm going to do what's half of 10? 5x. What's half of 25? Well, I could just put 25 over 2, couldn't I? Okay, so here is my answer. Y equals 1/2 x squared plus 5x plus 25 over 2. Okay, I'm going to graph this one. So we are going to start at our vertex, which is -5 and 0. So -5 and 0. Okay, I could find a couple of points, or I can go in and find it, but I know I can do 2 and 1, so I'm going to go over 2 and up 1, and I'm going to go over 2 and up 1. Ooh, look at how nice and fat that's going to be. Okay, ooh, oh, and I made that look ugly. So it's going to be nice and fat down in the bottom. Okay, flattened. Alright, so I guess we should find another one. So let's go here and do parentheses 1 divided by 2 parentheses x squared plus 5x plus 25 over 2. I'm going to just put in 12.5 because it'll be faster and easier. And I'm going to hit second in table. Let's see what I end up with that I can plot here. Looks like not a whole lot. That's going to go not a whole lot at all. Something's wrong. I've got something in here wrong. Let's see what I did. I'm going to do this again. I'm going to do 0.5 x squared plus 5x plus 12.5. And I'm going to do second in table. Let's look at them. Much better. Something happened there. I put something in wrong. Okay. So I've got -6 and 0.5, which looks good. -7 and 2. And then we could do -8 and 4.5. Or we could just go to -9. And we're going to hit 8, which is right up here. And then going on the other side, we would be positive. So it's going to be -1 and 8. -1 and 8. And I'm going to draw this nice flat parabola. Okay. Alright. So that's all that you're going to do for those. These are pretty quick over here. It says use transformations and the vertex form to determine a function rule for the quadratic. Okay, so all we're going to do is go through those questions again. Number 1, is it a reflection? Yes, it's a reflection. Okay, we're going to figure all this out by looking at our graph. The vertex is at, well, let's see here, 1, 2, 3. So x is 3, and 1, 2, 3, 4, 5. So the vertex is at 3 and 5. Okay? So it is moved, what? Up 5, over to the right 3 from the parent. Remember, we're always comparing it to the parent. Is there vertical stretch or compression? Well, if I go over 1 and down 1, it's right there. If I go over 2, 1, 2, 3, 4, it's right there. So no vertical stretch or compression. Okay. I need to put it in y equals a times x minus h squared plus k, plus or minus k. Okay. So what is my a? Y is equal to, well, it's reflected, so it's a -1. You can either put the 1 there or not, it doesn't matter. Alright, then you have x, and then my 3 is positive, so I'm going to go ahead and leave it as -3 squared. Okay, and then I have plus 5, and that's how easy that is. Okay, alright, and then we're going to do one more. Is there a reflection? No reflection. Okay, what is the vertex? The vertex is at 1, 2, 3, 4, 5 to the left. That's -5. 1, 2, 3, 4. -5 and -4. Almost did that one wrong. So we went down 4 and to the left 5. We have, let's see if we have a vertical. Ooh, yes, we definitely have a vertical compression, because look at that. We're going over 2, and oh, look at that. We're only at a half when we go over 1. So that tells me that I have a vertical compression of 1/2. Instead of being able to go over 1 and up 1, the parent would go more like this. We're only over 1 and up 1/2. So we have a vertical compression, and that vertical compression, the scale factor, I just proved it, is 1/2, because we went half as far. Okay, so then I can rewrite my y equals a times x minus h squared plus k. Remember that this is where it's going to change, because that's a -5. It's like saying x minus a -5. Okay, so then that changes to a positive. So y is equal to 1/2, that's my scale factor, times x plus 5 squared, minus 4. And that's it. So you're going to have a practice that is just like this, and have a great day.